And it's based on the area formula for a semicircle, which is relatively intuitive. Okay. Would it make sense that the area of a semicircle is half the area of a corresponding circle? Yeah. Okay. In terms of areas, that is true. What about in terms of perimeter? Was that true in perimeter? Is the perimeter of a semicircle exactly half that of a corresponding circle? No, because you have to account for this diameter as well, right? Okay, so if you combine those two relationships, if you're given a perimeter of this semicircle, can you find what its area would be? So just, again, take about a minute or two. See if you can work through the perimeter equation for a semicircle, find the radius, and once you have the radius, plug it into the area formula for that same semicircle, please. So again, in this problem, as well as most of these, you need to find the radius. I think that's the first element that needs to be identified. So if you know the perimeter is 16, we need to find an equation for the perimeter that involves the radius. So the perimeter of a semicircle is half of the circumference. So 1/2 of will represent circumference in terms of radius, 2 pi r. And then we add to that the diameter. Again, will represent the diameter in terms of radius, which is 2r. So here's our equation for perimeter. We can cancel the half and the 2 to get pi r plus 2r. Okay, now, we were told that this perimeter is equal to 16, so here's our equation. And then it's just a matter of solving for r. Well, anytime you need to solve for a variable, move all the terms that contain that variable to one side, which is already done here. And then you need to remove that variable from those terms. And the way that you do that is to factor it out. So we'll factor out an r, and that leaves a pi in the first term and a plus 2 in the second term. And then finally, it's just a matter of completely isolating it. So now you're going to divide by pi over 2. Divide by pi plus 2. And that eliminates and isolates your r. And so here is your radius. Now, if you want, you can put this into a decimal form right now, okay, or you can just leave it. I'm going to leave it and set up my area formula here in just a moment. Once we have our radius, we can now plug it into our equation. It's 1/2 the corresponding area of the circle, so 1/2 pi r squared. And we found our radius value to be 16 over pi plus 2. Okay, so here's the calculation that we're going to use. As far as entering this on your calculators, the way that you would enter this on your calculator, 1 divided by 2 times pi times, and then this whole fraction that's being squared. You need to be careful with your grouping symbols for this. So if you look to group this correctly, you're going to set basically your fraction that you're going to take to the power of 2. So kind of working from the outside in. Our numerator is 16, so we can write that divided by. And our denominator has multiple terms. So we need to group those multiple terms in the denominator. So we'll embed them within this other set of parentheses, pi plus 2. And so this would be the form that you'd enter on your calculators. And when you do that, you should get your solution 15.21 approximately. It's an area, so we're dealing with square units. So if you ever had to identify units, it would be centimeters squared for this one.